Okay, so parallel lines will always have the same slope. Equations of parallel lines will have the same x and y coefficients. So remember, a coefficient is the number that's in front of the variable. A variable is one of the letters of the alphabet. Okay, so if you can see in the first line, the line n, the 2x plus 5y minus 20 equals 0. So that equation, the coefficient of x is 2 and the coefficient of y is 5. Okay, so if you have another line that is parallel to the line n, well, it'll have the same x and y coefficients. So you can see here it has the same x coefficient, the same y coefficient. All that will be different is that the constant at the end will be different. So here it's minus 20. Here we just don't know what it is yet. It's called d. Okay? The symbol for parallel is those two little vertical lines. So k, the line k is parallel to the line n. It just spares us having to write the words is parallel to. So here you've got the line L, which is 3x minus 4y plus 6 equals 0. And if you're told that the line k is parallel to the line L, well then the format of line k will also take 3x minus 4y, and you can put in some other constant. It doesn't matter what it is. I could say minus 5 is equal to 0. So now the line L is parallel to the line k. So that's how you would write it. Okay. Now if you look at those three lines, they are all parallel. You can see they all have the same x coefficient, the same y coefficient, but their constants are all different. And if you look at the constants, you might notice the differences in like a translation difference, right? So if you look at the blue line, the constant is minus 8, right? If you look at the purple line, the constant was plus 2. The difference between the purple line and the blue line, like what has it shifted up by? All right, that, you know, the differences in values. And the same for the blue line to the red line. What has it shifted up by? Like they're equidistant, they're parallel from each other, so they're never going to meet. Okay, so you can come up with any equation of any line that's parallel to another line just by changing the constant at the end, and that will make it another parallel line to it. Because basically, remember, parallel lines have the same slope. So if you were to get the slope of, we'll say, these two lines here, and given that they're in the ax plus by plus c format, the quick way to get the slope, m equals minus a over b. For the line L, a is 3 and b is minus 4. So this would be minus a bracket. A was 3 and b was minus 4. A minus divided by minus is a plus. 3 over 4 remains as 3 over 4. So the slope of the line L is 3/4. And if I do the exact same thing for the line K, a is 3, b is minus 4. So the slope formula, minus a over b, that's going to be minus a bracket. A was 3, b is minus 4. A minus divided by minus is a plus. 3 over 4 remains as 3 over 4. So they have the same slope. Okay, so that makes those two lines parallel. And all that's in the difference between them is their constants. Next, we're looking at perpendicular lines. So when we want to prove that two lines are perpendicular, the proof will be if you get their two slopes, remember m represents the slope of line 1 multiplied by the slope of line 2 will give you an answer of minus 1. That's important to remember. That's the formula to prove that two lines are perpendicular. If you multiply their two slopes, you should get an answer of minus 1 if and only if they are perpendicular lines. Okay? So let's say we are given the following two lines, line L and line K. Okay, and I want to prove that the two of those lines are perpendicular. So I'm going to get their slopes. Now look at the format the lines are in. It's the ax plus by plus c format. So the quickest way to get their slopes would be to use the formula minus a over b. So the slope m of line L, m of L, a is 3, b is minus 4. So that's going to be minus a over b minus a bracket a, which is 3, all over b, which is minus 4. That tidies up to be 3/4. So that's the slope of line L. Now the line K, a is minus 4 and b is minus 3. So the slope of line K, it's going to be minus a, which is minus a bracket, a is minus 4 all over, b, which is minus 3. A minus divided by minus is a plus, and then you'll still have minus 4 over 3. So minus 4/3 is your slope of line K. So I now have their two slopes, 3/4 and minus 4/3, and all I want to do now is prove that they're perpendicular. So if you multiply their two slopes, you should get an answer of minus 1 if they're perpendicular. So if I multiply 3/4 by minus 4/3, you will get back minus 1. So I now know that the line L is perpendicular to the line K. Okay, in the next bullet point it says, flip and change the sign to get the perpendicular slope. Right. If you have the slope of one line and you're asked to go and get the slope of a line that will be perpendicular to it, that's all you have to do. Flip the slope upside down and change the sign. So if it was positive, it would now be negative. Okay, so for example, if you are told that the line B is perpendicular to the line C, and you're told that the slope M, the slope of B is 4/7, find the slope of C. Well, the fact that they're perpendicular means I can take the slope of the line B, 4/7, it's a positive slope, right? Well, then that means this one's going to be a negative slope, and just flip that upside down. So it'll be 7/4. That is the slope of line C. And again, I can prove that they're perpendicular because if I multiply the two slopes, so 4/7 multiplied by -7/4, top by top, bottom by bottom, I'll get -28/28, which is -1. So when you multiply the two slopes, you get an answer of -1. Well, then that's telling me that the two lines are perpendicular. So flip the slope upside down and change its sign. If it was positive, it'll now be negative. Or if it was negative, it would then be positive. And you then have the perpendicular slope. Okay, any line that will be perpendicular to another line will take the following format. So let's say the first line, which we'll call n, it takes the format of ax plus by plus c equals 0. Well, then any line that's going to be perpendicular to the line m, we'll call the other line the line n. All you have to do is switch your x and your y coefficients around. Okay, so a goes here, b will go there. All right. And then you change the sign that was on the y value. So if it was a plus, it'll now be a minus. Or if it was a minus, it'll then be a plus. And the last thing, the two constants will be different as well. So like if that was a +3, that one could be a -6. All right, the constants will be different. So that's how you write down the format of any line that's perpendicular to another line. If you have the equation of one of the lines and you're told go and get the equation of another line that will be perpendicular to it, you just swap the x and y coefficients, change the sign in front of the y coefficient, whichever it was. If it was a plus, it's now going to be a minus, because look, a up here is positive, but down here it's going to be negative because you changed the sign. And then the constants will be different. That was a c, that's a d. Okay, so if you look at this example, 3x minus 4y minus 5 equals 0. That's the equation of line n. If I want to write down what the equation of line m would be, given that m is supposed to be perpendicular to n, you can see I'm going to swap the x and y coefficients. So I'm going to put the 3 in front of the y, and I'm going to put the -4 in front of the x. Now that was a +3, but you can see when I put +3 there, I changed it to a minus. I changed the sign in front of the y value. And then I put on some other constant c at the end. Doesn't matter what you call that constant. You can call it +52 if you want, and it's all equal to 0. You can double check if that's correct, because if you go and get the slope of line n, and you go and get the slope of line m, and if you multiply the two together, you'll get -1. Here's a second example. If I am given the line L, which is 2x minus 3y plus 1 is equal to 0, and I'm told that the line L is perpendicular to the line K, find the equation of line K. Right, okay. So I'll swap the x and y coefficients. So the -3y, I'm going to put the -3 in front of x. Plus 2x, I'm going to put the +2 in front of a y. Now remember, you then change the sign in front of y. So I'm going to change it from a plus to a minus. And lastly, then you can put in whatever constant you want at the end. So I could put in -7 equals 0. So now the line L and the line K would be perpendicular. Now you don't have to put in a -7, right? You could put in just plus c. C is just some constant, okay? So now the line L and K are perpendicular, and I can double check by getting their slopes and multiplying them to get a -1. Okay, so using the formula -a over b, the slope of L, it's going to be minus a bracket 2 all over b, which is -3. That becomes 2/3. Minus divided by minus is a plus. And for the line K, A is -3, so it's going to be minus A, which is -3, all over B, which is -2. That's going to become -3 over 2. So they're my two slopes, and if I now multiply them together, I should get -1. If my two lines were perpendicular, that would tell me that the way I wrote the equation of line K would be correct. So multiplying the two together, top by top, bottom by bottom, you get -6 over 6, which is -1. Therefore, the line L and the line K are perpendicular, which means that format was definitely correct. Answer the following questions after those examples. So pause the video, go and do those questions. And remember, for question 4, it says investigate if the following lines are perpendicular to each other, or if they're parallel to each other, or if it's neither. So again, it's all about slopes. Get their slopes. If their slopes are the same, well, then they must be parallel lines. If their slopes are inverted, so flipped upside down and opposite signs, then they must be perpendicular. And you can also multiply the two slopes, and if they get an answer of -1, they're perpendicular. If none of those apply, well, then obviously the two lines are neither perpendicular nor parallel. Okay, the next example then. The line Q, which is 3x plus 2y minus 3 equal to 0, it's perpendicular to another line called P. The line P contains the point 4 minus 1. Find the equation of the line P. So, things to note, right? Perpendicular is the key word, so highlight it, right? So if the line Q is perpendicular to the line P, we already know what format it should take. You'll swap the x and y coefficients around. You will change the sign on the y value, and you'll add a constant, call it plus c, because the constant will be different from the -3 on that line, okay? Now, you can't leave the format with a plus c, which means you're going to have to use the extra information they gave in the question, which was this. The line you're looking for, the line P, it contains the point 4 minus 1. That's x and y. So I'm labelling it x and y. So once you know that a point is on a line, it should sub into it and it should solve it. And they're asking us to find the equation of the line P. Okay, so the first thing I'm going to do is I'm going to put down what format the line P should take. Remember, if it's perpendicular to the line Q, it should take this format. The x coefficient goes here, it swaps. The y coefficient goes there, it swaps. That was a +3, so now it becomes a -3. You change the sign in front of the y value. And then the constant, just call it plus c. It has to be different from that constant, okay? And it all equals 0. So that's the format of the equation of line P. If that's all you did, you're getting marks. But I need to figure out what c is. I can't just leave it as an unknown constant, okay? So now, the point 4 minus 1, they said, was on that line P. If a point is on a line, it should sub into it and solve it. So I am now going to go and sub 4 minus 1 into that equation and let it equal 0. So x is 4 and y is -1. When you sub in, you must use brackets. So it's going to be 2 times 4 minus 3 times -1 plus the constant c is equal to 0. So now just start to work that out. 2 4s are 8, -3 multiplied by -1 is +3, plus your c equals 0. Group your like terms. 8 plus 3 is 11. 11 plus c is now equal to 0. Bring the 11 over and subtract it, and you'll get c is equal to -11. Put a box around that. You have now found your value of c. So now I can sub my value of c back in to the equation of the line P. So it's going to read as 2x minus 3y minus 11 equals 0. And that's the equation of line P. Okay, the last example then is example 2. The line T is parallel to the line R. Okay, parallel now is your key word. Parallel lines have the same slope. The line R contains the point -1, 3. Find the equation of the line R. Okay, so if I know the line R is parallel to the line T, well then the line R should take the same format as the line T, which means it'll have the same x coefficient and the same y coefficient. The only thing that will be different is the constant at the end. It won't be a +2. So the first thing I'm going to do is I'm going to write down the line R is now going to look like this. -4x minus y plus something, so plus c, is equal to 0. Now, I can't leave it like that. I need to figure out what plus c is. So the only other information they gave me in the question is that the line R, so this line contains the point -1, 3. So if a point is on a line, it should sub into it and solve it. So remember, that's an xy coordinate. So x is -1 and y is 3. So I'll write that above it. Okay, and then we can sub it in to figure out what c is. Use brackets when you sub in. So it's going to be -4 a bracket, x is -1, minus a bracket, y is 3, plus your c is all equal to 0. Now tidy that up. -4 by -1 is +4. Minus multiplied by 3 is just -3, plus your c equals 0. So you've got +4 minus 3 plus c equals 0. Group your like terms. 4 take 3 is 1. So now it's going to be 1 plus c equals 0. Bring your 1 over and subtract it, and you'll get c is equal to -1. And now that I know what C is, I can sub my value for C back into the equation for R. So it's going to read as minus 4x minus y minus 1 equals 0. So that's your equation for the line R. Okay, so after those two examples, I want you to do the following questions. So remember, whether it says parallel or perpendicular, they're the key words. It's the exact same process each time. If you know they're parallel, they will take the exact same x and y coefficients, and all that will be different is the constant c. If you're told they're perpendicular, well then the format, you'll swap the x and y coefficients around. You will change the sign in front of the swapped x coefficient, and you'll obviously have a different constant as well. Then you sub in your points x, y to figure out what the unknown constant c will be each time. Okay, so those 5 questions, pause the video there now to do those questions into your copies.